Good evening, all. Students, I request please inform your friends to join the session. Roshit sir, good evening.
Yeah, good evening, Sushmita.
Yes, you can start the session, sir.
Okay, yeah. Students, can you ask your friends to join fast so that we'll start the session in 1 more minute? Okay, good evening, everyone. Yeah, good evening, Sanjay. Good evening, Mangesh. Good evening, Anurag. Good evening, Jinath. Good evening, Kajal. Good evening, Mamata. Good evening, Muskan. Good evening, Niharika. Good evening, Rani. So, how are you all doing? So, any assignment I was given yesterday? Did I give any assignment yesterday? Good evening, Tanisha. Okay. So, what was asked in what was discussed in the last session on your 11th day session? What is discussed? Yes, stack and cube, right? Good evening, Anand. Yes. So we discussed the stack and queue data structure yesterday, right? Good evening, Vinith. Yeah. So let me change the color. I wanted to go with blue today. Okay, so we have discussed stack and queue yesterday. We have implemented the stack and queue using array, right? So what is stack? Let us revise what is stack. So it is a LIFO data structure or it is a linear data structure, right? So LIFO in the sense last in, first out, right? The one which is inserted the last will be popped or deleted first, right? So your CD rack, yes. So you will have the, if you're designing the stack as like this, you should insert the elements over the top end itself. You can insert the elements over the top end itself. Okay. And if you want to delete also, you will be deleting it from the top end itself. So insertion operation is called as push operation. Yes. Whereas deletion operation is called as your pop operation, right? Deletion operation is called as your pop operation. Yes. So we will delete the elements from one end only, that is top end. We will insert the elements also from one end only, that is top end. Okay. Yes. The last element pushed onto the stack is the first one that will be popped up. Yes, exactly. So we will have other operations as well, right? You have your push operation, you will have our pop operation, we will have our peak operation, right? This will give the top, what is the data that was there on the top end, right? The top element data. And then you can have the size operation, and you can also implement is empty operation to check whether the stack is empty. Yes, you can also implement is full operation to check if the stack is, otherwise it will go into overflow, right? So these are all the operations you can perform on the stack. Okay. And this stack, as discussed yesterday, can be implemented in Java through array also. Okay, using array you can implement it. Otherwise you can go with the linked list approach as well. Okay. So yesterday we went with the array approach, right? So yesterday we went with the array approach. So if suppose if suppose I'm taking push of 10, push of 15, then push of 13, okay, pop, then I wanted to get the top of the element, okay, the top of the element, and I wanted to get the size, then I wanted to again pop, again size, again I will do push, okay, again I will be doing some 23. Okay, now I'm taking an array of size, stack of size. Basically, if I wanted to implement the array in the array format, I'll be declaring a size first of all, right? I'll be declaring a size of it. Okay, some 5 I'm declaring. Okay, so you will have an array here of 5 size, right? And initially, the top pointer, I will point it to -1. Okay, initially the top pointer I will point it to -1, and what I am doing here, I'm performing the first operation, that is push of 10 into this stack. Okay, push of 10 into this stack. So what will happen now? Top from -1 it will come to, you need to increment the top to 0. Okay, 0, 1, 2, 3, 4. You are incrementing the top here and then inserting the element. Then again you are incrementing the top, and then again you are inserting the element 15, and then again you are inserting the top, you are putting the element 13. Okay, 13, and then again you are inserting the top, you are performing the pop operation now. Pop in the sense, pop in the sense, pop in the sense you will be decrementing it. Okay, you will be decrementing the top, you will be decrementing the top, and then you will remove it. Okay, you will decrement the top and then you will remove it. Okay, then again you are doing the pop. Then what you will do again you will decrement you will remove the element and then you will decrement the top to here. Okay, so again top is, again here, what is the top element now? Top, you're calling the top function, the top is 10 here. Okay, top is 10 here, and size is also 1 year. Okay, size is also 1 year, and then again you are doing the pop here. Again you are doing the pop, means what will happen now? Top will be decremented to -1 back again. Okay, it will be decremented to -1 back again, and if you can do the size, if you call, it will give me 0, because when top is equal to -1, the size will be 0 itself, right? Yes. So for every addition, you will increment the size. To calculate the size, how you will do? You will increment the size. Okay, the current size, basically. The current size you will increment. For every decrement, for every pop operation, you will decrement the pop. Okay, you will decrement the size. And then now the size is 0, and then you are again pushing it. Means pushing in the sense, again what will happen? Here it will be 10 will be moving off, and what will be coming here? Your 23 will be coming, and the top will be here now. Okay, if you print now top element, it will be 23. The size will also be 1. Okay. Yes. Yeah. So how to write the algorithm? Basically, we have written the algorithm also yesterday, right? So how you will write the algorithm? So you will have you can write some implementation, stack implementation, right? Then what you're doing? You're making top to -1. Then you're taking stack size. Okay, stack is equal to new int of 5. Okay, the size of the stack. And then what you're doing, you can take a current size variable. Okay, you can take a current size variable. and that will be initially 0, right? And then you'll perform your push operation. You'll perform your push operation into data, and then what you are doing, you are just inserting into the stack the data. How you will insert? It should be pre-increment or post-increment of top. Pre-increment or post-increment of top. It should be pre itself, because you are incrementing first, because top is initially -1. You're incrementing to 0 and then you are inserting the data. Okay. So this is how you will do. First, you will check whether if current size double equal to stack dot length. When it is double equal to, you will not be able to insert. You will return some message stack is full. Okay. Otherwise, you can insert it, and then what you will doing, you need to increment the current size. Okay. So this will be the push operation, and the pop operation how you will be doing. Pop operation how you will be doing. Just you can decrement the top. Okay. You can otherwise what you can do, you can put a stack of top is equal to 0. If you wanted to put it to you can make it 0, and then you can directly you can directly decrement the top. Okay, you can directly decrement the top. You can directly decrement the current size as well. Okay, but you should check the condition here, the base condition, that is, if current size double equal to 0 means stack is empty. If it is empty, then what you need to do, just return it. Just return it means return some message stack is empty. Okay. So current size double equal to 0. This is your pop operation. And then top operation, how you will be doing? Top, simple, right? What you will do, just return top dot data. Okay, just return top dot like basically return stack of top. Okay, return stack of top. Okay, you can also check this condition here. If current size double equal to 0, this condition you can check it out. Okay, then next one is like returning your size. Anyways, you will directly return the current size in this. Return current size. Okay, so these are all the operations that you will perform within your stack data structure. Using array implementation, you will implement like this. These four functions. Four functions you will implement like this. Yes, are we clear? Yes. So these are all the operations you will be doing within the stack data structure. Okay. Then through linked list, how you will implement. Through linked list, how you will implement the stack data structure. Okay. So linked list, you remember linked list? What is linked list? What is linked list? We have taken two to three classes on linked list. Sir, what we need current size? We have top to maintain this, right? Yeah, you can. Yes, yes, yes. You can also, you don't need the current size also. You can directly maintain it through top itself. Okay. Means basically what you can do, return top less one. Yesterday I explained like that only, right? Return top less one. Like this you can increment. You can return also. No need to maintain the current size. Okay. Anyway, top will be the index of the array. Good understanding. Okay, then you can directly increment the top. Fine, fine. Okay, no need to maintain the, in the case of your array, You no need to maintain the current size. Okay. So linked list, what is linked list? So basically we'll have the node, right? Basically in Java it is called as an object, and this object is divided into two parts. First one is data part, second one is address part, right? This address is nothing but the address of the next node, right? Address of your next node. You will have your single linked list, double linked list. We have implemented this, right? So linked list, how you will implement for stack, how you can implement the linked list, like using linked list, how you can implement the stack. Okay, stack in the sense it should have only one end. Okay, it should have only one end. From one end only I can insert, from one end only I can delete, right? Is this possible through linked list? Is this possible through linked list? From one end only insertion, from one end only deletion? Yes. Is it possible? Yes, it is possible. So what I will doing, first top pointer I will make it to null. Okay, this top pointer I will make it to null. Then what I will do, I will create a new object. Basically I will create a new node. Okay, so first one is what, pushing off your 15, right? 10, 15 and 13. Okay, so what I will do, I will create a new node, that is 15, and this will be null, right? So what I will do, this the next node I will point it to top. This for suppose this is considered as temp. Okay, this is considered, the new node is considered as temp. So temp dot next I will point it to null. Okay, temp dot next I will point it to null, and then what means I will point it to top. Basically I will point it to top, and then what I will do, I will bring this top to here. I will bring this top to here. After pointing it to null, I will bring this top to here. Okay, I will bring this top to here. Okay, and then what I will do, if you wanted to insert another thing, 17, suppose I wanted to insert 17. Again, this will be considered as temp, right? Again, this will be considered as temp. So basically, this will again be considered as temp. Then again, temp dot next, I will point it to top. I will point it to top. Okay, ignore my drawing. Okay, so again I will move the top to temp. Okay, and then again if suppose 18 I'm inserting, this is considered as temp, right? This is considered as temp. Again what I will do, I will point it to second node. I will point it to top node. I will point it to top node. Then again I will move the top to temp. I will move the top to temp. And again, if suppose I wanted to insert 19 as well, what I will do, this will be temp node, and temp dot next will be pointing to top, then top is equal to temp. Okay, so like this, I will perform the push operation. I will perform the push operation. So you will do the push operation. Like this will be the data part will be given. And then what you will do, node temp is equal to new node of data, right? New node of data. Okay, and then what I am doing, new node of data, right? Then what I am doing, initially top is pointing to null. Okay, the top is pointing to null. Node top is equal to null. So what I will do, temp dot next is equal to top. Temp dot next is equal to top, means top will be pointing to null. This like this, and then I will move the top to temp. I will move the top to temp. Okay, top is equal to temp. So like this I will do. Okay, like this I will do the pushing. I will do the pushing, and then if you wanted to return the node also, what I will do, I will return top itself. I will return top itself so that you can traverse. Okay, so this is your push operation. This is your push operation. So if you are inserting 17, so now top is a tier, right? So let me rub this up everything. So initially top is pointing to null now. Like top is pointing to null, and then when you are pushing the 15, it is creating a new node here. It is creating a new node here and temp dot next. This is your temp node. It has created the temp node, and new node dot temp dot next is equal to top will be pointing to null. Okay, this will be pointing to null, and then I am moving the top to here. Okay, then I am moving the top to here. Let me remove this up everything. Yes, actually we are connecting the previous node. We are actually connecting the previous node. Okay, we are updating the top pointer to the last node if you observe. Okay, so now you observe, you'll understand, Anurag. Okay, now top is a tier. Okay, now top is a tier. Okay, and then I'm pushing the 17 now. I'm pushing this 17 now. So what will happen now? Node temp is equal to new node of 17. Means temp will be created with 17. Basically, new node will be created with 17. Okay, then temp dot next, then temp dot next, then temp dot next. Temp dot next is equal to top. Is equal to top means this link is created now. Okay, and then top is equal to temp means I am moving the top to temp. Okay, I'm moving the top to temp. Then I'm returning this top pointer so that you can traverse and you can print it or you can do anything you want. Okay, I'm returning this top pointer. Then again, if you wanted to print 18, if you wanted to print 18, then again, what will happen? The temp will be 18 now, and then temp dot next will be top. Okay, temp dot next will be top. Like this, the link will be created. Then the again top pointer I will be moving here. I'm incrementing the top. Okay, I'm incrementing the top. Then again I'm creating 19. Again I'm creating 19. I am moving the temp here. Temp dot next will be top. Okay. So this will be the updated node, the last node. Suppose if you wanted to return the top, how you will return it? Directly, can you return it? Return top dot data, right? Return top dot data. So directly you can return it. Means 19 will be coming. Okay. Then if you wanted to return size also, if you wanted to return size also, what you can do? Just you can return the here you require a size. You need to count the number of nodes, right? Number of rows you need to count. So you need the current size here. Okay, for every increment, you need to do with the size. Okay, current size plus plus. You can directly return the current size. Okay, current size you can directly return. Now let me know how I can do the pop operation. Now let me know how I can do the pop operation. Pop operation, how can I do? But sir, LIFO principle means last in first out, and for this we have traverse. Yes. Okay, can I do pop operation? Can you do pop operation? Yes, can you write the code for me? Pop operation, how I can do? I'm waiting for your answer. I will wait for 1 more minute. Please write your code for pop operation. Okay, good. Okay, so what you are doing, what we need to do for popping means you need to remove the top node, right? You should be removing your top node means you need to move the top pointer to the next node. This should be null, right? This should be null, like it should be deleted, right? This node should be deleted. So what you can do, good responses in the chat box. I'm happy. Okay, pop off data. Okay, pop off data. What you can do, mm, suppose int data what you are deleting, I will be storing it because I will be deleting, right? So I'll be storing it top dot data. Okay, then what I will do, okay, I will be moving the top pointer to the next, means this node I will be moving. Okay, so top is equal to top dot next. Okay, top is equal to top dot next. Before top dot next you can directly move, like make that top to point to null also. That is also okay. Okay, so we will also put yeah, I'm not passing, I'm not, I mistakenly written this. Okay, so just pop operation, and what you're doing, top is equal to null and top is equal to top dot data, then you can directly return the data, or you can also return the string as well that is been deleted. Okay, so like this you can perform the pop operation. Correct. So correct, Anurag, and who have given the responses. Rani, correct. Yes, you need to, you can also check the condition as well. If current size double equal to 0, then you can directly return it because there will be no elements in that case, right? Then, yeah, Suyash, correct. Yes. Okay. So why I'm moving top as null? Basically, like I'm making this as null. I'm making this as null so that it will be collected by the garbage collector. It will be collected afterwards by the garbage. This object will be collected afterwards by the garbage collector. Now the top is top. This is been named with top, right? So I'm making that as null, and then I'm moving the top pointer to top dot next. Okay, this will give me null pointer exception basically. Okay, so what you can do, this code will give me null pointer exception because what I am doing here, I'm making it as null, and then again I'm working on the same top null dot next. Null dot next in the sense like it will be null dot next, it will give me null pointer exception. This code will be giving me null pointer exception. So what you can do instead of that, if you wanted to make that as null, don't use the top variable only. Okay, so what you will do, you can use another variable node some temp or node deleted element is equal to top. Okay, then delete is equal to null you will do. Okay, delete is equal to null you will do, and then top is equal to top dot next. Okay, so if you are doing top is equal to null, then you are operating on the same variable here, null dot next, it will give me null pointer exception. Okay, so for that reason, what you should do, you should go with another variable you are taking here. So what will happen now, what will happen now what will happen now, this will be, so this is top, right? This will be top, right? So the top will be here. What I am doing, I'm making I'm giving another name to it, like delete. Okay, like del, like that some name I'm giving to this, and then I'm making this del as null. Like first I'm moving this, first I'm moving the top here, top is equal to top dot next, means this will be moved here, and then I'm making this del as null. Okay, null in the sense this will be made as null. Null means this will not have any reference. Okay, this will not have any reference. So it will be cleared from the memory at some point of time. At some point of time, it will be cleared. But if you don't mention also, it will be cleared anyways because you're not putting any reference to this node. If you're putting any reference to this node, it will won't be cleared. But if you do only top is called top dot next also, it will be cleared. Okay. If you do top is called top dot next also, it will be cleared because you're moving the top pointer to the front node. Okay, you are moving the top pointer to the front node. Okay, front node, and this will not have any reference. This object will not have any reference, so it will be collected by the garbage collector in Java. Okay, if it doesn't have any reference, it will be collected by the garbage collector soon by Java. Okay, are we clear? Yes, are we clear with the pop operation? Yes. So this is how you implement using your linked list stack, using your linked list. Okay. So now going back to queue, going to your queue. So let me take another color for queue. What color should I take? Okay, queue. So how does queue work? Queue work based on FIFO data structure, right? FIFO. First in, first out. The one which is inserted at the first will be removed first, right? Will be removed first. Okay. So it is also a linear data structure. Okay. So basically in queue, so in queue we have two ends, right? We have our rear end, we have our front end, right? So from rear end, I will insert the elements. Basically, I will call that operation as enqueue. Okay, I will call that operation as enqueue. And from front end, I will delete the elements dq. Okay, then if you wanted to get the top element, then you can go with the your rear element will be the top element anyways. No. Your yes, if you wanted to get the top element, so basically what is there on the top, your rear element will be the top element anyways. Okay, this is your peak operation. Okay, this is your peak operation. Okay, and then if you wanted to get the size, you should need to maintain some current size pointer, and you can get the size of this, and you can also maintain other operations like isempty. These things you can do the similar operations within the queue also. Okay, and this queue also you can implement using array also, you can implement using linked list also. Yesterday we have seen this array. Okay, yesterday we have seen this array. Suppose I'm taking 5 elements to explain 1 2 3 4 5. Okay, so I am taking the other things like instead of enqueue, I will write it as push itself. Okay, so some 23 push of some 70 push of some 15. Okay, and then I'm performing pop, then I'm performing pop. Okay, and then again I'm pushing up some 10. Okay, then again I'm popping up, then again I'm performing the pop. Okay, then again I'm performing the pop. So if you see this, so from rear end, I will be inserting the elements. From front end, I will be deleting the elements. If you wanted to, like initially, if you wanted to implement using array, so initially you will take two pointers, that is rear and front. That will be initially pointing to -1 itself. Okay. Then when you are inserting the first element will be inserted, and then the rear will be here, front will be here. At the rear position, you will insert, and the front also will be at the rear end itself. From the second element onwards, you will be just moving the rear end. Okay, you will move the rear end to the increment, you will do the increment of rear end, front end will be here itself. Okay, since from stack, you need to delete from queue, you need to delete from the front end. Okay, then 70 will be here. And then again, you are doing the rear, again, you will do the increment of rear. Okay, again, you will do the increment of rear, and this will be 15. Okay, this will be 15. And then again, if you wanted to do the pop operation, if you wanted to do the pop operation, then what you are doing, you are deleting this, you are deleting this, means this will be deleted. Okay, you can make it as 0, and then you need to increment the front pointer to here. Okay, front pointer to here. Now stack has two elements, that is 70 and 15. The queue has two elements, that is 70 and 15. And then again, if you're doing the pop operation, then again, if you're doing the pop operation, again, this will be deleted and the front pointer will be moving here. Okay. Then what you are doing, you are again pushing it, pushing the 10 here. Okay, some 16 here. So what will happen now? Rear will be moved to the front end. They will be moved forward, and then 16 will be inserted. And then again, you're performing the pop operation. Okay, again, you're performing the pop operation. This will be deleted, right? This will be deleted, and the front will be moved here. Now again, you are performing the pop operation. There is only one element here. If you observe, there is only one element here. Okay, if there is only one element here, what you will do, you will not increment the rear, you will not increment the front. Okay, just you will keep it as, since the queue is empty currently. Okay, after removing this element, queue will be empty. So in that case, what you will do, you will remove the element, and then you will point out this rear and front again back to -1, again back to -1. Okay, when front and rear are pointing at the same position, when front and rear are pointing at the same position, then you are reverting back to -1 again. Means now what will happen? Means now what will happen? Now the stack is empty. So front and rear. Now the queue is empty. So front and rear. 1, 2, 3, 4, 5. Okay. Front and rear will be again -1. Then again, if suppose again you are performing the operations push, 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 and then again you are performing push 70, again you are performing push 80, then again you are performing push of 90, then again you are performing there are like 5 elements, like 1, 2, 3, 4, 5, 6 elements over there, right? Now you are performing pop, pop, 5 times pop. Okay, 5 times you're doing the pop. Okay, so let's check now. These operations are not there. Okay, these operations I will delete now. Just observe this carefully. You need to tell me what are the edge cases. Okay, after explaining this, what edge cases I need to handle. Okay, now these are all the operations are all there. Like 6 operations of push, 5 operations of pop. Okay, now I'm inserting 23. 23 in the sense rear and front will be pointing to. Again, you observe rear and front will be pointing to the first element, and then 23 will be coming. Okay, and then 17, second element. In that case, I should just move the rear position forward. The front will be staying here itself, and this will be 70. And then again, I will move the rear to front, and again, I will be inserting 15. And then again, I will move the rear to next 10, and I will insert 70. Again, I will move the rear to front, and again, I will insert 80. And until this point, the operations are done. Now I'm doing this operation. See, before this, I wanted to perform some pop operation also. Now, if you see, can I insert now? Is it possible? Can I insert now? Is it possible? Can I get a quick heads up in the chat box? Can I insert 90 now? Is it possible? No, it is not possible because queue is already full, right? You need to check this condition also. For every push operation, you need to check whether current size double equal to size. In that case, Q is already filled. For suppose here I am performing pop operation. Before this 90, I am performing 2 times pop operation. Okay, 2 times pop operation. Then what will happen? 23 will be deleted. Okay, 23 will be deleted and the front will be moving forward. Again, 70 will also be deleted and the front will be moving forward. Now what will happen? Okay, now rear is at here and front is at here. Okay, and front is at here. Okay, so here the rear is at here. Now front is at here. Now I wanted to insert 90. Is it possible to insert this 90 now? Yes or no? Is it possible? Is it possible to insert 90? Yes or no? Yes, right. Because the places are empty now. There are empty spaces were there. Before it was full. All the places were filled. But now there are still slots are there. Slots are available. Seats were there in your seats were there for the movie for that particular movie in that particular ticket. They have cancelled the tickets. So the seats were still there, right? So I can insert it. I can give the tickets to another, right? So what I can do, I should not increment now. I should move to the front. I should move this rear position to the front. But the challenge is until now we have just incremented this. But now I can insert it. But the thing is, I can insert in the front. But until now, what I'm doing, I am moving the front to just forward plus plus. I'm doing the increment. But now what I need to do, I need to move this rear to here. So what I can do, one formula I can apply to move the trend to rear to beginning. Rear plus 1 percentile by size. Okay, rear plus 1 percentile by size. So rear is how much? It is 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. Right? So 4 plus 1, 4 plus 1 percentile by 5. How much is it? How much is it? Percentile in the sense remainder, right? 0, right? So what I can do using this approach, I can move the rear to here. I can move the rate to here and then I can insert the 90. I can insert the 90 here. Okay. Suppose again I am doing push operation. Push operation of 75. Push operation of 65, 55. Like the 3 times I'm doing the push operation. Okay. So 75. Push operation of 75. So rear plus 1. 0 plus 1. Percentile by size. 1 percentile by size. 1 percentile by 5 is nothing but 1 itself, right? So I will move the rear. Okay, I will move the rear here and then I will insert 70. I will insert 75. I will insert 75. Okay, I will insert 75 and then if you can see 65. Can you insert this 65 now? Is it possible to insert 65? No, because now the queue is already filled. Queue is already filled. Okay. First, suppose before this, I'm performing the pop operation for 2 times. Pop operation for 2 times. So now what will happen? This will be moved, right? This will be moved. This will be moved. Okay. Now rear will point, now front will point to this position, right? Front will point to this position. So can I insert now 65? Is it possible to insert 65? Yes. So what will happen? 1 plus 1. 1 plus 1 percentile by 5, which is nothing but 2 percentile by 5, which is nothing but 2. Right? So I'll be inserting 65 here. Okay, rear will be here. And then again 55 I wanted to insert. 55 I wanted to insert. Okay, 65 is there. Huh? Okay. 55 I wanted to insert. I will move 2 plus 1, 3. 3 percentile by 5 rare position. Okay. Now rare is at 55. Now I am doing pop operation for 2 times. Okay. Pop operation. Is this done? 80. I'm removing it. I'm removing the 80. But can it move forward? It should move forward or backward. It should move backward. So how should I move that to backward? What is the formula? Again the same formula. Front plus 1 percentile by size. Right? So again I will move this front pointer to first element. Again if I am doing pop, again I will move 0 plus 1 1 percentile by size. Again I move to here. So like this, I will declare the sizes of our. I will calculate the sizes of your front and rear. Are we clear until this point? Yes, everyone. Yes. Yeah. So yesterday we have written this code. Yes. So so basically, what the base conditions were? Base conditions were if stack. I need to check if the stack is empty. If the stack is empty or if the stack is full, right? Two base conditions. And then if rear double equal to front means stack will be empty. Stack will be empty. So what base conditions I will be checking off? Uh, Stack is like Q is empty. Okay, sorry, Q is empty. Q double equal to 0, right? The current size is double equal to 0. Or if Q is double equal to size, right? Current size double equal to size. And if suppose rear double equal to front, rear double equal to front means there is only one element there. There is only one element there. Means if I delete the front, if I delete the front, rear and front should point to -1. If I delete the front element, rear and front also should point to -1. This is the third condition. And then I will be calculating the sizes based on rear plus 1 percentile by size. Okay, or front plus 1 percentile by size. These are all the conditions I should check while inserting or deleting the elements from your queue. Okay, so let me go ahead to the code. If you can see, I have declared the size of the queue. Okay, and then front and rear are pointing to the -1, and current size is initially 0. Current size is initially 0, and the size, okay, and the size is nothing but q dot length. Okay, then pushing. How we are doing the pushing? I'm taking an element, and what I'm checking the base condition, if it is already equal to size, the current size is already equal size, means q is already filled. Then in that case I will just return it. Like I will stop that pushing. If else, if it is not, if current size is double equal to 0, means nothing is there, then I will move the front and rear to the first position. I will move the front and rear to the first position, that is 0th position. Then I will insert the element. I will insert the element at the rear end. I will insert the element at the rear end. Okay. Then if suppose it is not empty, there is one element or two elements over there, then in that case what you need to do, you need to increment the rear, and then you can insert the element here. You can insert the element here, then you will increment the current size as well. So this is the push operation. This is the push operation. Can you try doing this until this point? Then I will move into the pop operation. Can you try doing this part until this point? Then I will move into the pop operation. I'll give you 1 minute of time. Please try to do this code, and then I will move into the pop operation. Yes, we are incrementing the current size. We are incrementing the current size. For every push, I will increment the current size. Okay, the size will be q dot length, and for every push of my elements, the dynamically I will increment the size. Yes, if it is equal to size, it will not be pushed, right? Anyways, if it is, I'm starting it from 0. If it is equal to size, then I cannot insert any more elements. So again, I've explained you clearly. You are not listening, and then you will ask again questions, Anurag. So, like when the queue is already filled in the sense why you will have empty spaces? Can anyone answer to his question, please? When the queue is already filled, means current size will be what? Current size will be 5, right? If suppose 1, 2, 3, 4, and then 5 over there. Okay. Now the current size is how much? Current size will be 5, right? If you are popping up, then the current size will decrease to 4, right? The current size will decrement to 4. Yes, now it is not filled. The queue is not filled. Then when you perform push operation, it will go inside. It will not be equal to 5, right? It will not be equal to 5. Then in this case, it will do the operation, right? When it is not equal to size, so basically the size is 5. 1, 2, 3, 4, 5. If suppose it is not equal, then in this case it will again move to the current size, right? Like it will move inside. This condition will be failing up. This condition will be failing off. It will move to the next condition. It will check the next conditions. Okay. So let me know, guys, once you have executed this, I'll move forward. Yeah, I can share that code, but you will not be able to, like, you will just paste it up there, right? So instead of that, you need to type it up so that you will understand something. So only I was stopping it here. I can push the code here and then I can move forward. But the thing is, you will just copy it up. You will not see the code perfectly fine. Okay, so for that reason, I'm not pasting it. Okay, next one, pop operation, how you'll be doing. The base condition is if it is already empty, you will check. Otherwise, if it is containing only one element, if it is containing only one element, then front and rear should be pointing to -1. Else, what you will do? You will find out the front size. You will increment the front and then current size minus minus. Okay. Then okay. Then top in the sense if current size double equal to 0, you will return just -1. Otherwise, you will return the front element. Okay, you will return the front element. Then current size means nothing but you will return the current size. and this will be the operations will perform along the thing. So what I'm doing here, I'm pushing 15, 20, 25, and 30. Now if I do the pop operation, what will be deleted? 15 will be deleted, 20 will be deleted, 25 will be deleted. So what will be there? Only 30 will be there. Now if I give the current size, what will be there? Let me print the top as well. Sys out. So sys out of q dot top. Okay, q dot top, and then q dot current size, q dot pop. So here the Q will be top with 30, and then current size will be 1, and then pop means nothing but pop is nothing but it will also delete 30, and then Q dot top will be -1, Q dot top will be -1, Q dot current size will be 0. Okay, let me check whether this will work. Yes, 30, 1, -1, 0. Okay, 31, -1, and 0. Okay, so I'll be sharing this code with you. Please do that. Okay. Yeah, I'm sharing the code. Try to do it. Okay, I've already shared the code mod. You can check it. Okay, so this is how you will implement using array. The next one is using your linked list. Linked list, how you can implement it? Linked list, how you can implement it using linked list. Using linked list, how you can implement it? So rare and rare will be pointing to null. Your friend will also be pointing to null initially. Okay. Suppose if you are inserting 15. Okay. Suppose if you are inserting 15. It is not deleting. Suppose if you are inserting 15. Okay. This is some new node I'm taking. Okay. New node. Now what will happen? New node dot next will be pointing to front. Okay. New node dot next will be pointing to, you need to move the rear pointer, right? Okay. It's not correct. Okay. New node dot next, you will point it to rear. Okay. You will point it to rear. And then you will move this rear and front from null to here, new node. Okay. Rear and front to here. This is using, this is your head node, right? This is while insertion of your head node at that side. Then if here the main drama starts, like inserting the next node. Yeah, I'm inserting in the linked list. Okay, now you are inserting 16. Now you wanted to insert 16. So what you will do? What you will like, this is your new node now. This is your new node now. Okay. This is your new node now. And what you will do? So now it is pointing to rear, right? So new node dot next will be pointing to rear. So now we have moved the rear to here, right? Rear to here. So I'm taking up here this one. Okay. So now rear dot next is equal to new node. Okay. So what will happen now? This will be moved off, and rear dot next is equal to new node, and then you will be moving the rear to next node. You will not move the front. Front will be here itself. Only rear you will be moving to the new node. Okay. Then again, if you are inserting 17, what you need to do? This will be the new node now. This will be the new node now. Okay. And then new node dot next, rear dot next is equal to new node. Rear is equal to new node. Okay. So this will be the push operation. This will be the push operation. Okay. That will be the push operation. Okay. So what you are doing now, push of some element if they are giving. Okay. So what you are doing, you are creating a new node. New node is equal to new node of data or element. Okay. And then what you are doing, new node, like if 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 print double equal to -1 and rear double equal to -1. What you need to do, you will be inserting new node dot next will point to new node dot next if it is the first node. Okay, if it is the first node, new node dot next will point to rear. Okay, new node dot next will be pointing to rear, and then rear front is equal to new node. Front is equal to new node. Rear is equal to new node. Okay, so this will be the front is equal to new node. Rear is equal to new node. Okay, so this will be the first node. Okay, when it is the first node, this is the thing. Okay, otherwise what you will do, just rear dot next is equal to new node. Okay, rear dot next is equal to new node. Okay, like this you can do it. Okay, yeah, that will also work. Okay, so if it rear dot next will be equal to new node and rear is equal to new node. Rear is equal to new node. Okay, so you can, the double times I'm writing here, right? Double times I'm writing here. Yeah. So anyways, it will be pointing to null only, right? This new node dot next initially it will be null itself, right? So you need not to point again to null only. Okay. If front double equal to null and rear double equal to null. Okay. Rear double equal to null. Then what you are doing, new node dot next is equal to rear, front is equal to new node, rear is equal to new node, rear dot next is equal to new node, and rear is equal to new node. So this is like anyways, the first node will be pointing to, like it is null only, to enter here, right? So you need not, you can write this, and this is rear dot next is equal to new node. Okay. So if it is else condition, you'll be writing, and then you can write this. Okay, then current size plus plus, current size plus plus. So this will be the push operation. This will be the push operation. Then can you implement the pop operation? So top operation, how you will implement top operation? Just returning the front dot data. But you should check whether it is null also. Whether front double equal to null, you will check that also. Okay. You can, otherwise if it is not equal to null, then directly returning front dot data. Then size also returning your current size. Okay. So can you tell me this one, pop operation now? How can I do the pop operation? How can I do the pop operation? How can I perform pop operation? So basically, yes, correct. So in the just move this print pointer to next node. That's it, right? Print pointer to next node means this link will be broken. Okay. So basically front is equal to front dot next. Like that you can move this. Okay. Front is equal to front dot next. And then returning your front node itself. Returning just the front node. Okay, returning just the front node. So this will be the pop operation. Okay, so this is how you will do it with the linked list approach. Okay, you will do it with the linked list approach. Okay, so next one, next one, stack and queues implementation we have done with array and linked list. Okay, stack and queues using array and linked list were done. Okay, now I wanted to implement this stack using queue as well. Using queue as well. Can I do it? I wanted to implement this stack in the sense leaf or data structure, but I wanted to implement using queue approach. I wanted to implement using queue approach. Is it possible? Is it possible? So stack has two ends, right? Your rear end, your front end, right? From rear end, you will insert the elements. From front end, you will delete the elements, right? So suppose 15, push of 10, okay, push of 13, then pop, okay, then push of 70. Okay. Then if you wanted to get the top end of your stack, okay, top end of your stack, and then size also if you wanted to get, you can get it. Okay. Now, initially, rear is pointing to -1 and front is pointing to -1. So you're inserting the 15 now. But you should behave this as a stack, okay? So rear and then front. Rear and front, what you will do, push of 15. Okay, push of 15. And then you are again inserting 10. You are again inserting 10. But what you are inserting 10 here, you are incrementing the rear. That's okay. But if I perform a top operation, what you are returning basically, in the top operation, what you are returning basically, it is still 15. As per our queue, this is correct. But now this should behave like stack. This should behave like stack. Okay, this should behave like stack. So what you should be doing then? What you should be doing then? Means, is this correct? Returning 15 is correct when I call the top operation. When I call the top operation, returning 15 is correct. Yes or no? It is not correct, right? So means 15 should be after 10. The front should be at 10 now. Yes. So what I will do, the same thing I will do, like I will move this, whatever is there before rear end, those elements, I will move it after. Okay, I will move it after 10. I will move it after 10. Okay, and then I will increment the front. I will increment the front to rear. I will increment the front. Okay, I will increment the front to rear. Okay, again I'm inserting 13 now. Again I'm inserting 13 now. Okay, again I'm inserting 13 now. So where it should be inserted? So basically, that means the rear will also, I will also ship the rear also to here. Okay, 15. I will also ship the rear to here also. Okay. Now, where the 13 should be inserted, again it should be inserted at this point, right? At this point. Okay. Now rear is at this point at 15, at 13. Okay. Rear is at 13. It's 8:30. Attendance people have come. No, right? It's 8:27 only, Achal. 8:28. Okay. Like a New Year, 12 o'clock, it will be coming, right? You will be making your attendance for celebration. In the same way, you're asking here also for attendance. Are you counting time or are you put any stopwatch before you to see 8:30? Just listen the class, man. This is useful, not attendance. Okay. So yeah, I'm explaining Anurag. You will understand now. Okay. You will understand now. Uh, I will remove all this stuff. So front is at now second element. Okay. So front is at here. Rear is at here. Right. Now what I am doing, I have inserted 13. So rear is at here. Now this is not correct, right? This is not correct. The front should point to here, this element. So what I'll be doing means this element should be afterwards. This element should be afterwards. So what I will do, I will remove what were there before rear. I will remove what were there before rear. Those all elements, I will remove it and I will place it at, I will place it at after 13. Okay, after 13, 10 and then 15 and then 15. Okay, again, like while removing, what I will check, I will increment also. I will increment rear to here. Again, I will increment rear to here. Okay, then again I will move the front to rear. Okay, before what is there to that rear, I will like once again I will explain it clearly so that you will understand. I messed it up. Messed it up. Okay, listen carefully now. How I will do this. Okay. Okay. So I'm inserting 15 here now. Okay. 15 here now. So rear will be at here. Front will be at here. Okay. Front will be at here. And then I'm inserting 10 again here. So now what will happen? Now what will happen? Rear will be moving to this position. Right. But you see, front should point to here. 10. Right. It should not point to 15. So for that reason, what I will do, I will move this front to rear. I will move this front to rear, and then what I will do, whatever is there before this element, those elements I will move it up. I will move it up from here to front. Okay, front of rear element means I will increment the rear to here, and then I will insert 15 here. I will insert 15 here. Means now what will happen? Like rear will be at, front will be here, rear will be here. Okay. Then again what I am doing, I'm taking some extra. Okay. Okay. Again what I am doing, I'm inserting 13. I'm inserting 13. Okay. So for inserting 13, again I need to increment the rear to this position. Then again I will insert 13. Now what I will do, I will move the front to rear. I will move the front to rear. Okay, I will move the front to rear, and then whatever elements were there before, whatever the elements were there before, okay, those elements I'll be pushing forward by incrementing the rear. So I will increment the rear. I will insert, I will insert 10. I will insert 10 here. Okay, I will insert 10 here. Then again, I will increment the rear. I will increment the rear. Again, I will insert 15 here. Again, I will insert 15 here. Okay, again, I will insert 15 here. Okay, so if you can see now, we can see now front is at top element only. Front is at, yes, every time we run the loop. Correct. Every time we run the loop because queue we are converting it to stack, right? So definitely we require a loop. Okay. Then again, I wanted to push some 17 as well. Push some 17 as well. Then what I will be doing, I will increment the rear to 17. I will increment the rear to 17. Then what I will do, I will move this front to rear. Okay. I will move the front to rear. Whatever is in there before 17, this 13, 10, 15. Okay. These all things I'll be moving it afterwards again. Okay. So means what will happen now? 10. I will increment the, okay. The 10 will be coming here. Okay. 10 will be coming here. Then, so whatever is inserted before this 13 and then 7, 10 and then 15. Okay. Will be coming afterwards. Okay. So what will happen? After 17, it will come basically. So after 17, what were there? What will come? Okay, 15 and then 10 and then 30. Okay, now rear is at this point. So like this, it will go on. It will go on. You need to remove all the elements and need to make it in the front. Okay. So that is how you will implement the stack using queue. Okay. So let me go ahead and write the code now for your push operation. Okay, for your push operation. So I'll be taking a queue. Okay, I'll be taking a queue. Okay, then what I will be doing, I will take the size of this queue first. Queue dot size. Okay, I'll take the queue size of this queue, and then I will push it up. I will not implement again. I will just use a push operation or enqueue operation from the library, and I will push that element. Okay, I will push that element. Okay, then what I am doing, I am from I will run a loop, means before elements what were there, I need to take it to the front. Okay, before elements what were there, I need to take it to the front. So I should be starting from n minus 1. So basically size my, like it should start from 1 to that particular size what was there. Okay, 1 to that size what was there. Okay, so size of the stack until s, it should run until s. Okay, until s what were there, those elements what I am doing, I am taking it to the front. Okay, q dot push off, q dot push off. What I will insert, I will insert at the top. I will insert in the top of stack. I will insert in the top, means nothing but in the front end I'm inserting, right? In the front end I'm inserting. Okay, so like this I will perform this operation, and I will pop out all the elements that were there in the, I will pop out all the elements from that position. Okay, I will pop out all the elements. After pushing all the elements, I will pop as well. Okay. After pushing all the elements, I will pop as well. Okay, so I will increment the size. Okay, I will increment the size and I will pop out the elements. Okay, so this is how I will be doing. When I'm pushing it up, I'm calculating the size, how many elements are there. Okay, suppose the size is some 3. Okay, size is like this. Okay, size is some 3. Then what I will do, I will run the loop from I to size. Okay, I to 1 to size basically. From 1 to size, I will run the loop and then I will push all elements that were there front end. So 1 to size 1, 2, 3. All the 3 elements what were there before that I will insert in the top end of the stack. Top end means in the front end of the stack. Front end of your queue. I will insert and then I will pop it up. So this is a push operation. This is a push operation I will be performing. Okay, this is a push operation I will be performing. And then if you wanted to do the pop operation, if you wanted to do the pop operation, so pop what you are doing, just you can pop it up. Q dot pop. So the same thing in the front end, from the front end only you'll pop it up, right? So directly you can pop it up. So top, what I will do, just you can write Q dot top. If you wanted to get the size, Q dot size of the stack. Okay. So like this, only the push operation will change. Okay, whatever are there elements in the front in the previously, that I'll be moving forward. That I'll be moving forward. Are we clear with this? Are we clear with this? Yes, everyone. This is too much for today. Huh? We have 2 more again. Like traversals is there, and I've also planned to teach 2 lead code problems as well. 2 LC problems on 2 famous problems. Those were. So I wanted to like uh, like do this also. Three problems were left, and I have 20 minutes to cover. Traversals I need to teach, and then 2 LC problems. Okay, so what I will do, one traversal I will teach it. I will teach now, and after this, like again, I need to implement this also. Like only one thing is done, right? Stack using queue, stack using queue. I need to also do this, right? Queue to stack. I need to implement the queue using stack also, right? Using stack also, I should implement the queue. That is also left, right? So using stack, I should implement the queue. Can you try this out today? Okay, can you try this out? Using stack, you need to implement the queue. Implement the queue. He's exhausted of doubts, Suyash. So only is crying today. So every minute he will have some doubt, right? Today he got many doubts. So because of that, Anurag is exhausted. Okay, so this I'll be giving it as homework to you. Okay, as assignment to you. Using stack, you implement the queue. I have told how to implement the stack using queue. Now you need to do using stack how you can implement the Q1. You should write the code for this. Okay, this will be the assignment for today. Okay, and then I will be moving into the traversals part. Okay, traversals part. So stack traversals basically, stack traversals. Traversal in the sense, what is traversal? Linked list traversal. Traversal in the sense moving from one node to another node, right? In the same way, stack traversal means you are moving from one end to another end over the stack, right? So we have there are like 3 traversals over there. We have one is infix traversal, postfix traversal, and prefix traversal. Okay, infix, postfix, and okay, and prefix traversal. Okay, So suppose I am writing an expression. So for an expression, we'll do this traversal basically. In stack, we'll do it for an expression. Okay, expression means what? Can anyone answer me? Expression is what? What is expression? Whoever tells correct, I'm giving 1 point to them. Okay, this one. What is expression? Fast. Let's see who tells it fast in the chat box. Operator. Okay. Full answer I want. What is expression? Only operators will not be there in the expression, right? Okay. Anurag, is it your definition only or some Google definition? Expression can be anything like string or mathematical computation or true or false. Also included special characters. If it is your definition, then I can give it it's up. Okay, 1 point to you. An expression is a combination of values, variables, operators, or function calls produces using a single result when evaluated. Okay, Nagesh. How many combination of variables, constants, and operators? Correct. How many is correct? Simple definition I want, not much. Okay. So combination of variables, constants, operators. Correct. Okay. So basically operators and operands. Mod is correct. Operators and operands. Expression is nothing but yes. We will. I can understand it. Mod. Yeah. So expression is nothing but it contains operators. It contains operators along with operands. Along with operands. So operands in the sense, it can be A to Z, it can be 0 to 9. Okay. It can be anything. And operators in the sense, you will have your star, minus, plus, percentile, division, then floor basis. So these are all considered as your operators, right? These are all considered as your operators, right? You have mod as well. Okay. So along with this, if you're writing some expression like this, a plus b into b plus c, like c plus d, this is considered as an expression, right? This is considered as an expression. Okay. Here infix like I this is nothing but a this is nothing but a this is nothing but a infix expression, right? This is called as a infix expression because in between there were like operators over there. You have the operator here, you have the operands. In between the operands, you have the operator. So this is called as infix expression. So this is evaluated as infix. And postfix in the sense, postfix in the sense, you will have the you will have the suppose AB I'm writing, you are writing afterwards. Okay, you are writing all the operands afterwards. Then again, if you are writing CD, okay, you will write the operands afterwards. So this is called as your post like postfix expression, right? Whereas prefix expression is called as prefix in the sense you will write the operands before, right? You will write the operands before. Okay, so star will be coming here, and then you will write your CD. Okay, this is called as your prefix expression. Okay, this is called as prefix expression. Okay, so this is how you will have this prefix, infix, and postfix expressions. Okay, infix, postfix, and prefix expressions. Okay, so this is nothing but your expression, or we will evaluate an expression based on the operator. Okay, so there are like some priorities out there. There are like some priorities are there in the operators also, how you should evaluate. So basically, the power operator is the highest priority. Is the highest priority. I can take it as someone. If I give the ranking, this is one. Okay, then you have your plus, minus. Okay, this operator will be of second priority. Okay, this operator will be of this operator will be of the third priority, whereas you have the star, division, percentile. These are all considered as second priority. Okay, so you have the power as highest priority, then star, division, and percentile comes under second priority, and then this is the third priority. Okay, third rank, first rank, second rank, third rank, and then you have the braces. These comes under your fourth priority. Okay, so this is how the your precedence will work. Ah, yes, BODMAS, exactly. BODMAS. But BODMAS precedence is different, and BODMAS that is different actually. Precedence is different, and priority to precedence is different, and BODMAS is different. BODMAS is useful in the case of your calculation, right? Yes. So if suppose like this there, like this there, suppose this is there like this 2 power 3 and star 9, like this you are writing plus 10 10 by 2 plus 3. Okay, can you tell now which is the most priority? What is the most priority here? Like you need to evaluate this one or this one. So when there are both braces over there, then definitely you should consider this one only, right? This will be of equal priority. This will be of equal priority anyways. Okay, this will be of equal priority anyways. So you will consider the first one only, right? The first brace only based on this, right? You will give the precedence order, the priority to this one only, right? In this, so like that. Okay, so like that, power will be having the greater priority than braces. Okay, power will be having the greater priority than races. Okay, so this is how the precedence order and the infix, postfix, and prefix expressions. Okay, so tomorrow I will be discussing like you're feeling like too much, right? So I should not burn your mind also. Okay, so for that reason, what I will do, I will do this prefix to postfix expressions conversion or traversals. Okay, prefix to postfix or infix to postfix using stack. Okay, this thing I will implement tomorrow. Okay, infix to postfix or prefix, this thing I will implement in tomorrow's session. Okay, this traversals. And then today I wanted to give one another assignment also. So today assignment will be bit like means today assignment problems are bit interesting. Please try them. Okay, online stock span, one assignment I'm giving. Okay, online stock span. So basically, if you can observe here, if you can observe here, like the input will be given like this. Okay, the input will be given like this. So stock spanner, and stock spanner means you should initialize the stock span. Okay, you should initialize it, means you should initialize your stack. You should initialize your stack, and then next in the sense you will be inserting the 100. Okay, you will be initializing your stack. Okay, and then you will be inserting the 100. You will be inserting the 100, and then what you need to do means basically you are calculating here how many times the stocks you bought the stack. One problem we have seen in a race, I guess, stack buy and sell problem we have seen, maximum profit problem, stack buy and sell Kadanes algorithm we have seen there, right? So here if you see 100, you bought it on this day. Before this day, there is no less than. How many days is lesser than or equal, you need to find it out basically. So 100, before this nothing is there, so you are returning 1. In this case you are returning 1. And here you see 80, before this it is greater only, so it will be again 1 only here. Then 60, before this again it is greater only, so you are returning 1 only as output. Next 70. 70 you see lesser than is 60. Here 80 is not greater, but 60 is lesser than 70. So what you should return here? 2 days. 2 days the stock span. The span of stock is 2 year. Okay. Then you see 60. 60, here it is greater only. Again it will be 1. Again it will be 1. Previous day stocks you need to compare. Previous day stock prices you need to compare. Okay, previous day stock prices you need to compare. They should be lesser than or equal to the 2 days price. Then it has maintained that span. Like that you need to count that span. Okay, so if you can see 75, 60 is lesser than, 70 is also lesser than, 60 is also lesser than. So what will be the stock span now? 3 plus 1, which is nothing but 4. Okay, along with this day, 3 days it continued, the less price. Okay, 4 days. Then here it is 6. Here it is 6 because 85. So 80 is there, 60 is there, 1, 2, 3, 4, 5, and then 6. So like this, you need to print out the output. So try this problem. This is very interesting problem. Okay, try this out. And another interesting problem also I will be giving it to you. Okay, and then another interesting problem for assignment, trapping rainwater. This is asked in many interviews. This trapping rainwater problem is asked in many interviews. Okay, so many product-based companies will ask this model kind of question. Okay, not exactly this model, but this model will be covered. Okay, see, add one. Here they have made it as add one. Okay, so if you can see trap raining water. So if you can see this graph, these are all buildings. Okay, these are all buildings. Okay, how much water you can accumulate, that you need to return between these buildings. You have poured the water, whether it is flowing up. Flowing means you should not count. Flowing means you should not count in between the buildings how much you can store. Means there is one upper large tall building is there, one slow building is there, one small building is there. Between small and big buildings, how much water you can accumulate, that units you need to return. Okay, so if you can see here, There is one building. This one building is there. This is of one weight. Okay, one height, and this is of two height. Okay, between this, how much you can accumulate? The accumulation you can do it as like 2 minus 1, which is nothing but 1 unit you can accumulate here. 1 unit you can accumulate here. And then if you can see here, this is of height. This is of height how much? This is 2 and this is 1. And this is 1, this is 3, right? This is 3. So 3 minus 2. How much you can accumulate here? Two amounts of water you can accumulate. 3 and this is 1 unit, this is 1 unit, and this is 2 units. 1, 2, 3, like 4 units, 5 units, and then here 6 units. 6 you should return as output. So trapping rainwater problem. Please try this out. This is also interesting. Okay. So these two problems along with the like this one, right? Stack, using stack, you implement the queue. Using stack, you implement the queue. Okay. So I don't know you are doing your assignments or not, but I am giving it to you. It's your thing. It's your headache, whether you do or do not do. The classes will continue. I will teach other problems, other concepts, but it's your thing, whether it's your honesty, whether you will do, whether you will try it out. Okay. I will continue my work. Whether you will continue or not, you should decide. Okay. So on that note, I'm winding up the session here. Before that, Suyash, sir, after completion of the course, we'll be having interviews, like your college interview, like you play, what interviews you're asking about? I did not understand your question. Like Sushmita can probably answer that. Okay. So on that note, I can wind up the session here. Okay. So thank you so much for joining. Have a good night. Over to you, Sushmita.
Yeah, thank you, sir. We'll meet again by tomorrow. Thank you so much. After completion of this course, we'll be having interviews. No, not definitely, because this is just for 15 days of program. We are not conducting any interviews or placements, as this is a student development program for just for a knowledge. So there will be no any interviews or something from this program. Okay, thank you all. Yeah, yes, exam we will be conducting, assessment we will be conducting in the last day of the session, that is day 15. It is for 50 questions and 50 marks for 1 hour. Yes, definitely we'll conduct the assessment. Yes, Anurag, in XLR we conduct many programs. So if you are interested, you can be in touch with us. You can drop a mail to ed@xlr.com. We will like our team member will contact you. Okay, fine. So we will wind up for the day. Thank you all. Thank you, everyone.